Hello. Hello.
Hello, sir.
Yes. Hello. Walaikum salam. Alhamdulillah. Alhamdulillah. Okay. Okay. Hmm. Hello.
Yes, sir.
We start. Should we start? Chalo. Okay. Today we are starting with the word what is spontaneous process. Now, what is a spontaneous process? Any process, any process that takes place on its own without external influence is called as spontaneous process. Any process that takes place that takes place on its own without external influence, without external influence, ये क्या आ रहा है यार? Any process which takes place without external influence, without external influence is called spontaneous process or irreversible process. For example, if we take a table and there is a water on it, इस पर water है, this water will fall down. So this is a spontaneous process. Water falls from a higher level to lower level without any external force. Electricity flows from higher potential to lower potential. Electricity flows from higher potential to lower potential. It is a spontaneous process. Heat flows from a higher temperature to the lower temperature. If there are two bodies, one is hot and other is cold, the heat will flow from hot to cold. This is a spontaneous process. If we take a beaker containing water, You add salt to it, the salt will dissolve and you'll get a solution. You don't have to heat it, you'll get the solution. If you take acid and to that you add a base, you add a base, acid will react with the base and form salt and water. This process is called as neutralization. If you take a beaker, if you take a vessel containing small pieces of ice, the ice will melt and you will get a solution. To melting of the ice, flow of heat from cold hot body to the cold body, neutralization process. If you take a cup of tea and keep it on the table, is a hot cup of tea, keep it on the table, the coffee or the tea will become cold after some time because the heat from that coffee or the tea will come in the surrounding. So all this process are called as a spontaneous process. Okay. So you can give the example of spontaneous process. First, neutralization of acid by base. Second, melting of ice above 0 degree Celsius. Then flow of water from higher level to lower level. So these are all spontaneous process. Now, the point, the characteristics of spontaneous processes. Characteristics of spontaneous process. Characteristics of spontaneous process. Number one, it takes place on its own and it does not require any external force. It takes place on its own and does not require any external force. Number 2, it takes place in one direction and the process cannot be reversed. It takes place in one direction and it cannot be reversed. You cannot reverse unless some external force is applied. The process cannot be reversed unless some external forces arrive. Unless some external force is applied. That means if the water is falling from higher level to lower level, it will fall on its own. It is spontaneous. But you can make water to flow from lower to higher. You can make, but for that you'll have to apply some pump, and that pump is external force. Okay, it takes place in one direction and it cannot be reversed unless some external force is applied. पानी ऊपर से नीचे आएगा, लेकिन नीचे से ऊपर भी पानी जा सकता है, लेकिन उसके लिए पंप लगाना पड़ेगा. So that pump is become an external force. Number 3 point. Reversible process or spontaneous process is a fast process. Is a fast process. Number 4. The process continues till equilibrium is reached. यानी प्रोसेस कब तक होगा? Till a equilibrium is reached. Spontaneous process continues till equilibrium is reached. इसका मीनिंग समझे? I'll give you an example for that. Suppose you have got a two body. One is at 75 degrees Celsius and other is at 50 degrees Celsius. This is a hot body compared to this. So heat will flow from here. Temperature of this will go on decreasing and temperature of this will go on increasing till both the temperature become equal. Till both the temperature, it becomes here 57 and this also become 57. This is called as equilibrium. यानी हीट कब तक फ्लो होगा? तब तक जब तक दोनों का टेम्परेचर इक्वल नहीं होगा. That means if there are two bodies of different temperature placed close to each other, the heat will flow from a body of higher temperature to the body of lower temperature till both the temperature become equal and equilibrium is reached. So spontaneous process continues till equilibrium is reached. Or we can also say in our direction, spontaneous process will lead in a direction which leads to equilibrium. एंड ये स्पॉन्टेनियस प्रोसेस उस डायरेक्शन में जाएगा जिस डायरेक्शन में इक्विलिब्रियम रीच होगा. स्पॉन्टेनियस प्रोसेस proceeds in the direction in which equilibrium is reached. Spontaneous process proceed in the direction in which equilibrium is reached. Okay, ये हो गया characteristics of spontaneous process. Now, next what we are going to see,
सर लास्ट पॉइंट क्या है?
spontaneous process proceeds in the direction in which equilibrium is reached. It is fourth point. फोर्थ पॉइंट को दो तरीके से डिफाइन करने, दोनों मीनिंग एक ही है. अब ये हॉट बॉडी और कोल्ड बॉडी, लोअर से हायर पर टेम्परेचर हीट फ्लो होगा क्या? नहीं होगा. अगर लोअर से हायर जाएगा दोनों टेम्परेचर इक्वल होंगे क्या?
नहीं होगा.
जब हायर से लोअर जाएंगे तो दोनों टेम्परेचर इक्वल होंगे ना. तो स्पॉन्टेनियस प्रोसेस उसी डायरेक्शन में जाएगा जिस डायरेक्शन में इक्विलिब्रियम इज अटेन और रीच.
ओके सर.
Okay, so that was point number 4. Now I am going to see relation between energy and spontaneity. Energy and spontaneity. Okay, let's see. Generally, spontaneous reaction takes place in a direction in which energy of the system is lowered. Spontaneous process takes place in a direction in which energy of the system is lowered. What is the meaning of this? Spontaneous process takes place in the direction in which energy of the system is lowered. यानी स्पॉन्टेनियस प्रोसेस उसी डायरेक्शन में जाएगा जिसमें उसकी एनर्जी कम होगी। वो कभी ऐसे डायरेक्शन में नहीं जाएगा जिसमें एनर्जी बढ़ेगी। टेक फॉर एग्जांपल HCl when mixed with NaOH. As soon as you mix it, it will form NaCl solid, NaCl aqueous, sorry, plus water, and your delta H will be equal to minus 57 kilojoules per mole. 56, बस इतना ज्यादा यूनिट में जाए. Now this is what is the meaning of this? Exothermic. Exothermic means energy is released. So acid react with base and form salt and water, and energy is released. It is an exothermic process. सेकेंड एग्जाम्पल में वही देता हूं, 75 डिग्री सेल्सियस एंड 50 डिग्री सेल्सियस. हीट यहां से इधर फ्लो होगा, इसकी एनर्जी विल डिक्रीज. हीट यहां से फ्लो होगा, सो एनर्जी इसकी डिक्रीज होगा. तो ये हीट किस डायरेक्शन देगा? इट विल गो फ्रॉम हायर टेम्परेचर टू लो, सो दैट एनर्जी इज डिक्रीज. Okay, so we can be tempted to say that exothermic process are spontaneous process. Energy release, इसका मतलब energy of the system is lowered, इसका मतलब energy is given out. Energy is given out, that means that process is exothermic. So we can say for a time being, थोड़ी देर के लिए हम ये बोलते हैं कि exothermic process are spontaneous process. बोल जा सकते ना, बिकॉज ये रूल है कि स्पॉन्टेनियस प्रोसेस उसी डायरेक्शन में जाएगा जिसमें एनर्जी ऑफ द सिस्टम इज लोवर्ड. Energy of the system is lowered, that means it is an exothermic process. So we are tempted to state that we are tempted to state that spontaneous process are exothermic, or either word other word I'll use, exothermic process are are spontaneous. लेकिन ये हमारा स्टेटमेंट is not correct, this statement, but it is not true, because there are processes which are endothermic, but spontaneous. There are processes which are endothermic, that means energy is increased, but was spontaneous. Example, melting of ice. I'll give you the example. Melting of ice. Water solid converts to water liquid. Delta H is equal to 6.01 kilojoules. It is endothermic. Yes or no? ये
Yes.
एंडोथर्मिक है कि नहीं?
Yes, sir.
endothermic.
Why? Because delta H is positive. आइस को खाली रखो ट्रे में, डिजॉल्व हो जाएगा. जस्ट कीप द आइस इन अ प्लेट, इट विल डिजॉल्व. दैट में अपने आप डिजॉल्व हो जाएगा. But it is an endothermic. Melting of ice is endothermic. But is endothermic because delta H is positive. But it is spontaneous. I'll take another example. Dissolution of the salt. Dissolution of sodium chloride salt in water is spontaneous but endothermic. We have to give some proof. NaCl solid कि जब पानी में डालोगे वो डिसॉल्व हो जाएगा, अपने आप डिसॉल्व हो जाएगा. It will dissolve on its own and it will form a solution. But delta H here, we know how much it is, 4 kilojoules. So this is dissolution of the salt. It is a बीकर ले लो, उसमें पानी डालो, it will dissolve on its own. Oh sorry, बीकर ले लो, पानी डालो और उसमें थोड़ा सा pinch of salt डालो, it will dissolve. But when it dissolve, it absorb heat. Delta H is 4 kilojoules. It is endothermic. So we cannot say that we cannot say that energy will decide the spontaneity. We cannot decide the spontaneity of the reaction on the basis of energy. Hence, we cannot decide spontaneity on the basis of energy changes. So there is no relation between energy and spontaneity because exothermic reactions are also spontaneous and endothermic reactions are also spontaneous. So whether energy increases or decreases, or in spontaneous process, energy may increase as well as decrease. There is no fixed rule. Okay. तो ये हो गया.
सर एक बार दिखाइए
Hello, loudly please.
सर रिलेशन बिटवीन सर ये दिखाओ ना सर आपस
क्या?
स्लाइड दिखाइए ना यहाँ पर रिपीट सर.
अच्छा देखो, तुमको ये स्लाइड मिलती है कि नहीं? मैं भेजता हूँ ये स्लाइड्स डेली. मैं स्लाइड्स
यस
भेजता
सर.
हूँ, पीडीएफ फॉर्म में भेजता हूँ मैं.
सर कल मिला हम लोगों को पीडीएफ.
कल मिला? कितना
कल
मिला?
ही मिला.
कल हम लोगों को मिला 5-6 मिले होंगे.
हाँ राइट राइट. एक्चुअली पहला मैं डायरेक्टली भेजा था, वो ओपन नहीं हो रहा था, तो मैंने उसको पीडीएफ में कन्वर्ट करके भेजा. तो आज भी मैं इमीडिएटली भेज दूंगा.
सर उसमें एक ही पीडीएफ 2-3 बार था.
एक पीरियड दो बार था.
हाँ सर.
ओके चल. नाउ we'll see if energy cannot decide the spontaneity, then how you can decide the spontaneity of the reaction. कैसे बोल सकते कि ये रिएक्शन स्पॉन्टेनियस है? by using entropy. Entropy is a fund is a thermodynamic property. Dynamic property which measures the entropy of the system. Entropy is the measure entropy is a measure of disorder or randomness of the system. It is denoted by S. We cannot measure S. We cannot measure S but we can measure delta S. If delta S is positive, entropy of the system increase. Entropy of system is increase. If delta S is negative, entropy of the system is decrease. I'll explain you what is that. तुम्हारे घर में अगर 2-3 साल का बच्चा है, उसको एक जगह पे रखेंगे, वो घर में एक जगह पर बैठेगा? If there is a child of 2 or 3 years, will it remain at one place in the room?
No, sir.
No, he will move about in the whole room. But if there is an 85 or 86 years old lady in the room, will it move all over the room or will sit at one place?
One place.
One place. So the randomness of the lady is less. The disorder of the lady is less. But the randomness of the child or disorder of the child is more. So we say the entropy of the lady is less and entropy of the child is more. Yes. वो बच्चा कब तक घूमेगा खेलेगा? जब तक उसकी एनर्जी कम हो जाएगी और फिर बाद में सो जाएगा. And entropy increases, the students will be having disorder, and the energy will decrease and it will attain an equilibrium and वो सो जाएगा. तब उसकी एंट्रोपी कांस्टेंट रह जाएगी. We'll take, this is a human example. Let us see the chemical example. In solid, particles are very closely packed. Particles are closely packed. They are not free to move. randomness is less, entropy is less. These are solid particles. They are not free to move. But this solid particle, when heated, the particles are free to move everywhere. This is liquid. If this is further heated, it is further heated, it will convert into gas. The particles are free to move. This is solid. In liquid, particles are free to move. Therefore, their entropy is more. Their entropy is more than solid. In gas, particles are more free to move. Randomness is more. Therefore, entropy is maximum. Okay. Therefore, entropy of a gas is greater than entropy of a liquid, and which is greater than entropy of a solid. Let us see some reactions in which entropies increase or entropies decrease. If you take iodine solid and you heat it, you will get iodine gas. Delta S will be positive. This is solid. Randomness increases. Randomness increases. Entropy increases. Therefore, delta S is positive. Take this example, H2G. On heating, convert into 2H2G. दोनों भी G है. What do you expect? Entropy will increase or remain constant? दोनों गैस है. क्या आपका ख्याल है? दोनों गैस है. When both are gas, you compare the volume. इसमें 1 वॉल्यूम है, इसमें 2 वॉल्यूम है. तो more the volume, more will be the randomness. Less the volume, less will be the randomness. अगर वॉल्यूम ज्यादा है तो स्पेस ज्यादा है, particles will have more entropy. And when volume is less, the entropy will be less. So here delta S is positive. Third, if we take potassium chloride, solid, on heating, you will get 2 KCl and 3 oxygen. This is gas. This is solid. This is solid. Now tell me whether entropy will increase or decrease. What is the expectation? ये सॉलिड है, सॉलिड से सॉलिड बनता है और गैस भी बनता है. So either entropy increase हो गए. When a substance goes from solid to gas or solid to liquid, entropy increases. So your delta S will be positive. Okay, delta S will be positive. Take this example, fourth one. 2 hydrogen G combined with oxygen G to give you water L. The gas is converted to liquid.
Entropy decreases.
Delta S entropy will decrease, so it will be negative. Gas is decrease. Gas to liquid, entropy decrease. Randomness decreases. Entropy decreases. Therefore, delta S is negative. Okay. So this was entropy. Now we know that entropy is a measure of randomness or measure of disorder of the system. Entropy is a measure of randomness or disorder of the system. I agree. But how you can measure entropy of a system quantitatively? That means how you can find out the value of that entropy change quantitatively. हाँ, सॉलिड से गैस हो गया तो हम बोले हाँ एंट्रोपी इंक्रीज हो गया, लेकिन कितना इंक्रीज हो गया, कितना इंक्रीज हो गया या कितना डिक्रीज हो गया, ये क्वांटिटेटिवली कैसे निकाल सकते हैं? हाउ यू कैन डिटरमाइन एंट्रोपी क्वांटिटेटिवली? So quantitative definition of entropy. If there is a system and if this system absorbs Q quantity of heat, at temperature T, then delta S of the system will be equal to Q upon T. Q upon T. It may not necessary that heat is absorbed by the system. It can be given by the system. It can be given by the system. If it is given by the system, then delta S will be minus Q upon T. If heat is released, Q will be negative. If heat is absorbed, Q is positive. So, what is entropy change of a system is a process. So, here I can give the definition. Quantitative definition. Entropy change of a system entropy change of a system in a process is equal to the amount of heat transferred to it in a reversible process, in a reversible manner, divided by temperature in which the transfer takes place, in which transfer takes place. So delta S is equal to Q reversible upon T. Delta S is equal to Q reversible upon T. Okay. Delta S is equal to Q reversible upon T. Q reversible will be negative if heat is evolved, and Q reversible will be positive if heat is absorbed. Okay. If Q is negative, delta S will be positive. Then delta S will be negative. And if Q is positive, then delta S will be positive. Okay. So अगर एंथैल्पी चेंज निकालना है किसी भी रिएक्शन में, you should know how much heat is absorbed or how much heat is revolved. You can also write this way: delta S is equal to delta H upon T. Because what is delta H? Energy changes. Whether a heat is absorbed or heat is evolved. This is हो गया. Now we'll see next is entropy and spontaneity. Entropy and spontaneity. relation between entropy and spontaneity.
सर ये सिलेबस में नहीं है
क्या?
सर ये रिलेशन बिटवीन एंट्रोपी एंड स्पॉन्टेनिटी
That is called second law of thermodynamics. This is nothing but second law of thermodynamics.
सर रिलेशन बिटवीन एंट्रोपी एंड स्पॉन्टेनिटी सेकंड लॉ ऑफ थर्मोडायनामिक्स सब डिलीटेड है.
किसके लिए? इस साल के लिए?
यस सर.
For this year?
यस सर
सर
Yes,
Let me
sir.
check. Let me check. लेकिन आपको नीट और जेई के लिए तो है ना? नीट और जेई के लिए तो है ना? Let me see. I've got a syllabus. Hmm. मेरे मोबाइल में हो. That means you don't want this. If you don't want this, I'll not do it. But it is there for the JE and NEET. JE and NEET, nothing is reduced.
ओके सर फिर कर लेंगे.
Okay, now I'll just see, confirm it. कि मैं किधर ऐसा रिडक्शन देख के जब पढ़ाता नहीं हूँ. I teach everything. और ओपन हो जल्दी. टाइम लेता है. वाईफाई तो चालू है. जाने दो. Okay, let's see. Second law of thermodynamics. Relation between entropy and enthalpy, spontaneity. Okay. Consider example delta solid converted to water. Delta H is 4 kilojoules. not 4 kilojoules. Delta H is how much? कितना किलो जूल्स है? 6 point. चलो, in this the delta H is equal to delta H is equal to 126. पॉजिटिव है, वैल्यू नहीं दिया है, इट इज पॉजिटिव. एंट्रोपी इंक्रीजेस, therefore it is spontaneous. It is spontaneous. Okay. Now, why it is spontaneous? Because randomness increases. If you take hydrogen peroxide, it will form water plus oxygen. Delta S is 127 positive. Entropy increases. Both this process are spontaneous. Both this process are spontaneous process. बर्फ को रखो, बर्फ पानी में कन्वर्ट होता है. हाइड्रोजन पेरोक्साइड को ओपन रखो, it will give water and oxygen gas will be given out. You have to do nothing. It will take place on its own. But in both these cases, the entropy increases. So we may be tempted to say that entropy of the system increases in a spontaneous process. From this example, we are tempted to say that entropy of the system increases in a spontaneous process. Entropy of the system increases in a spontaneous process. यानी जो प्रोसेस स्पॉन्टेनियस होगा उसके एंट्रोपी सिस्टम जो जिस प्रोसेस में एंट्रोपी इंक्रीज होगी वो स्पॉन्टेनियस होगा. बट इट इज नॉट ट्रू. देयर आर सम प्रोसेस विच आर स्पॉन्टेनियस बट एंट्रोपी इज नॉट इंक्रीज. एंट्रोपी इज नॉट इंक्रीज लेकिन स्पॉन्टेनियस है. लेट्स सी. But there are processes in which entropy of the system is decreased, but it is non-spont, but it is spontaneous. But there are processes in which entropy of the system is decreased, but it is non-spontaneous. I'll give you the example. Hydrogen G, when combined with oxygen G, it from water L. It is two volume, it is one volume, and this is liquid. That means gas plus gas give you liquid. Entropy is decrease. एंट्रोपी चेंज इसका कितना है मालूम? -327 जूल पर कैलविन. एंड डेल्टा एच इस प्रोसेस का कितना है मालूम? डेल्टा एच ऑफ दिस प्रोसेस इज -527 किलो जूल. -5 डेल्टा एच. तो इस प्रोसेस का डेल्टा एस नेगेटिव है, डेल्टा एच भी नेगेटिव है. इसका मतलब 527 heat is evolved and entropy has decreased. Once this process is started, nobody can stop this process. हाइड्रोजन एंड ऑक्सीजन एक बार कंबाइन होने चालू हो गया तो इनका बीच में स्टॉप नहीं हो सकता. इतना फास्ट ये प्रोसेस अपने आप होता है. इट टेक्स प्लेस ऑन इट्स ओन. Only you have to start that process. Right? So this is a spontaneous process. But delta entropy is decreased. So we cannot decide the process is spontaneous or non-spontaneous from the entropy change of the system alone. We cannot decide whether the process is spontaneous or non-spontaneous from the entropy change of the system alone. We have to also consider entropy change of the surrounding. We also have to consider entropy change of the surrounding. Therefore, the second law is stated, a second law of thermodynamics stated that total entropy of the system and its surrounding increases in a spontaneous process. So, spontaneity of the process cannot be decided on the spontaneous on the cannot be decided on the entropy change of system alone. We have to consider entropy change of surrounding too. Therefore, second law is stated. Second law of thermodynamics is stated as that the total entropy of the system and its surrounding of the system and its surrounding increases in a spontaneous process. That means delta S total equal to delta S system plus delta S surrounding should be greater than 0 if delta S total equal to delta S system is greater than 0, then the process is spontaneous. तो ये हो गया spontaneous. So दोनों को करना पड़ेगा. So final conclusion, what we can say from second law, if delta S total, if it is greater than 0, spontaneous. If delta S total is less than 0, non-spontaneous. If delta S total is equal to 0, the reaction is in equilibrium. So ये याद रखो. Okay, so this was relation between spontaneity and next we'll see Gibbs energy. Next we'll see Gibbs energy. It is a thermodynamic property denoted by G, and G is equal to H minus Ts. We cannot measure G, but we can measure delta G, and delta G is equal to delta H minus T delta S at constant temperature and pressure. I'm not doing in detail because it is not in your syllabus, but I'm giving you the formulas which will be useful for solving the sums in MCQs. So delta G is equal to delta H minus T delta S. Now why you have gone to Gibbs energy? Gibbs energy dg, it deals only with the system, and previous one kya tha? Delta S deals with the from you can decide a spontaneity from delta S, but you have to consider system as well as surrounding. That means you can know whether system is process is spontaneous by using delta S of the system as well as delta S of the surrounding. But surrounding is very, very large compared to system. And a chemist only studies the system. A chemist does not study the surrounding. So if you want to decide whether a process is spontaneous or not, you must know the Gibbs energy of the system. So to decide whether the process is spontaneous or not by taking only the system, then you have to use Gibbs energy. आप कोई भी कर सकते हो, डेल्टा एस से भी निकाल सकते हो और डेल्टा जी से भी निकाल सकते हो. Now what is that relation we have got? Delta G, if it is less than 0, process is spontaneous. If delta G is greater than 0, process is non-spontaneous. And if delta G is equal to 0, the process is in equilibrium. And how you'll come to know delta G? By using this equation. हर रिएक्शन का डेल्टा एच होता है, हर रिएक्शन का डेल्टा एस होता है, हर रिएक्शन का टेम्परेचर होता है, एंड यू कैन फाइंड आउट डेल्टा जी and you can decide whether the process is spontaneous or not. Yes, we can decide whether the process is spontaneous or not. Then, so if you see, when delta G is 0 at equilibrium, delta G is 0, therefore delta G equal to delta H minus T delta S. 0 is equal to delta H minus T delta S. T delta S is equal to delta H, temperature is equal to delta H upon delta S, and this is called equilibrium temperature. Equilibrium temperature. Okay. Then one more part. Gives energy and equilibrium constant. Gives energy and equilibrium constant. Delta G is equal to delta G0 plus ln Q. Delta G is equal to delta G0, ln का मतलब नेचुरल लॉग, उसको मैं लिखता हूं 2.303 log to base 10 Q. Log to base 10 Q. सॉरी, मैंने मिस्टेक किया. RT and here also RT. RT natural log Q, and here also log to base 10 Q. What is Q? Reaction quotient. Reaction quotient. Now, what is reaction quotient? See, if you have a reaction, A moles of A combined with B moles of B to give you C moles of C plus D moles of D. Then Q is equal to C raised to C D raised to D upon A raised to A into B raised to B. Q is reaction quotient. दूसरी तरफ बेटा A plus B equilibrium, C plus D, K is equal to C raised to C D raised to D A raised to A B raised to B. This is equilibrium constant. And this is reaction quotient. There is a difference between Q and K. When reaction is in equilibrium, then it is called equilibrium constant. If the reaction is not in equilibrium, then it is a reaction quotient. So reaction relation क्या है? What is the relation? This. Now, at equilibrium, नहीं at equilibrium पहले वो नहीं करता हूँ. At equilibrium और चलेगा. Q is equal to K there and delta G is equal to 0. At equilibrium, Q is equal to K and delta G is equal to 0. So it will become 0. This equation will become 0 is equal to delta G 0 plus 2.303 RT log 2 base 10 K. So it will become what? Minus delta G, or delta G is equal to minus 2.303 RT log 2 base 10 K, where K is in equilibrium constant. हो गया. So this was the theoretical part. K you can find out by this formula. Okay, so this is how you can find delta G0 Kc, or you can say delta G is equal to minus 2.303 RT log 2 base 10 Kp. What is Kp? Kp is equal to partial pressure of C raised to C into partial pressure of D raised to D upon partial pressure of A raised to A into partial pressure of B raised to B, and that is K. So this is the reaction and we have completed with the chapter. अभी थोड़ा बहुत न्यूमेरिकल करेंगे एंड ये चैप्टर कंप्लीट होगा. नेक्स्ट टाइम आई एम गोइंग टू स्टार्ट विथ सॉलिड स्टेट. विच अदर चैप्टर्स आर लेफ्ट माय स्टूडेंट्स? कुछ चैप्टर बचा है?
सर सॉलिड स्टेट्स बचा है फर्स्ट चैप्टर.
ये हो गया. सो
सॉल्यूशंस हो गया है और इलेक्ट्रोकेमिस्ट्री केमिकल काइनेमेटिक्स हो गया है.
ओके, हो गया ना. ये इलेक्ट्रोकेमिस्ट्री हो गया ना.
यस
ये
सर.
कभी अभी हो गया, पहला हुआ? Okay, okay, sure, doesn't matter. Okay, now next time I'm starting with solid state, but today I'll doing little numericals and then I'll leave you. Okay. I'll just drink a water and come. भाई मेरा पानी का पानी. Hello. Chalo. We start with a numerical. चल. क्या हो गया भाई? Numericals on spontaneity, entropy, and gives energy. Textbook, sum number 13, page number 88. Delta H 0 is equal to minus 219 kilojoules. Delta S 0 is equal to minus 21 joule per Kelvin. Determine the reaction is spontaneous or non-spontaneous.
सर डेल्टा एच में पॉजिटिव दिया है.
पॉजिटिव दिया है. ओके,
No, sir.
पॉजिटिव.
Minus 21 joule per KE.
21 इधर 21
Delta H 219 kilojoule.
कहाँ? It is positive. It's okay. Determine whether process is spontaneous or not. Determine reaction is spontaneous or non-spontaneous. बोलो. Delta G is equal to delta H minus T delta S. Delta G 0. Delta H 0 मालूम है 219. टेम्परेचर कितना है? टेम्परेचर कितना है?
नहीं दिया है सर.
दिया है indirectly. What is the difference between, आपको क्या दिया? डेल्टा एच दिया है कि डेल्टा एच 0 दिया है?
Delta H
0.
0. That means it is standard condition. It is standard enthalpy. Standard enthalpy means enthalpy at temperature 25 degrees Celsius and 1 atmospheric pressure. So it is 298 Kelvin. Delta S क्या दिया है? 21. But I have to convert into kilojoules. 21 into 10 raised to minus 3. यही प्रॉब्लम आता है. ये जूल्स में रहता है और ये किलो जूल्स में रहता है. So into minus 21 into 10 raised to minus 3. So temperature is 298 for standard enthalpy. So it will be 219 plus हो जाएगा minus into minus plus 0.298 into 21. मैंने ये 10 raised to minus 3 को चेंज किया. So 298 multiply by 21, what I'll get? 892. 2 8 is 16, 1 carry, 2 9 is 18 and 1 19, 1 carry, 2 2 is and 5. तो कितना होगा? 8 15 12 6. Okay. So कितना होगा आपका? What will be the answer? So 219 plus 6.258 ऐड करो 9 and 6, 15 to 225.258 kilojoules. Yes, it is positive. Delta G is positive, na?
Yes.
Yeah, delta G is positive. ये कहाँ गया भाई? क्यों नहीं लिखता है? Delta G is positive. Delta G is greater than 0. Therefore, reaction is non-spontaneous. Okay, therefore reaction is non-spontaneous. Two 98. Okay, so this I have completed the sum. Now I am taking the second sum. Textbook, sum number 14, page 88. Page 88, sum number 14. What is given? 2H2OL, 2H2OL plus oxygen G, giving you 2H hydrogen peroxide L, delta H 0 is 196 kilojoules, delta S 0 is minus 126 joule per Kelvin. Now you have to find out that you have to find out whether it is spontaneous or non-spontaneous. Standard condition दिया है. That means you are given temperature as 298. To find out delta G, delta H minus T delta S. Delta G 196, temperature 298 into minus 126 into 10 raised to minus 3. Find the value. 0.298 into 126, minus into minus plus. So आंसर क्या आएगा तुमको? पॉजिटिव आएगा कि नेगेटिव आएगा? आंसर क्या आएगा डेल्टा जी का?
पॉजिटिव सर.
पॉजिटिव है ना? Therefore delta G 0 is greater than 0, so it is non-spontaneous. Non-spontaneous. Therefore no change over temperature. ओके, ये हो गया 2 सम्स। और क्या है तुम्हारा, कोई सम्स इसके ऊपर है? ओके, okay, so you have completed the 2 sums. Let me see any good sums I have got. Okay, so we stop here. Today the class is over. Hello, madam. मैडम, अरे कोई है मैडम जी उधर? Because number of students have decreased, otherwise I would have started with the solid state. Solid state को 3 दिन लगेगा. Hello. हॅलो मॅडम, अरे कोण आहे का तिथं?
हाँ सर.
हा, आज सब संपलं.
हेलो
आज संपलं लेक्चर.
सर, आपका आवाज नहीं आ रहा है मुझे.
आवाज आज कंप्लीट लेसन खत्म हो गया. मेरा
हाँ,
चैप्टर
सर.
भी खत्म हो गया, थर्मोडायनामिक्स.
थर्मोडायनामिक्स.
हाँ, एंड नाउ आई एम गोइंग टू स्टार्ट नेक्स्ट टाइम विद सॉलिड स्टेट. ओके, सो नेक्स्ट टाइम मेरा कब थर्सडे को होगा या फ्राइडे होगा, जो भी होगा बता देना मुझे.
जी सर जी.
हाँ,
मैं एंड कर दूं फिर आपका हो गया तो.
एंड कर दे बेटा.